Okay, now we're doing forces review. Once again, there's a review for speed, there's a review for acceleration, and now we're doing F net equals ma review. So let's get started on the right side. Just so you know, on our review resources, I also put the original notes because I do think they're very helpful. So if you have not looked through these, excuse me, these are on Kami. And I really encourage you, if you're struggling with forces, to re-go through these notes. There's a lot of good examples in here. Videos are just to the right all the time. So as you go down, each page has a video, a few videos on the right, and they go through how to do questions like this. Okay, so today's video is on this one, is me doing some more examples. How do I solve problems? So I want to start again just by starting. What types of units are we going to be using when learning about forces and mass and acceleration? Well, we need to be able to identify them by their unit type, okay? And so if we see a 5.7, we don't know, but once we see kilometers, we know that we're talking about a D for distance, right? Kilometers is a distance. That's how far you travel. I went 5.7 kilometers. You're wondering, well, which direction, right? Uh, that's not a speed, it's a distance. 97N. N stands for newtons. This is a way that we measure force. So this is a capital F force. Okay. Another N is down here, 650 newtons. That's another force. Okay. 38 kilograms. Kilograms is a mass unit. This is also kind of new. We often use pounds, but kilograms is used like in grocery stores, grams, or kilograms, we use 1,000 grams. It's a great way of measuring mass. Meters, 89. M divided by S. This is distance divided by time. M is a distance, S is a time, but when they're distance divided by time, we call it a V for velocity. Okay? And this is 212 S seconds, so this is a time. Here we also have a distance divided by time, but this time is squared. So we might be thinking velocity, but this is not a velocity. This is an acceleration because there are three things: meters, seconds, 2 seconds. And so it's a speed that is changing. That's an acceleration. This one as well. Distance, time, time. This is another acceleration. Okay, it's important that we're able to do that. And so when we move on to this, we're using F net equals ma. As a triangle, it looks like this. F is on top, F net. And we got equals m times a. So this is how it looks as a triangle. A 30 kilogram dog, this is a mass, accelerates, this should be an acceleration at 58.58 meters per second squared. This is our acceleration. We want F net, determine the net force, okay, is mass times acceleration. And so what we're going to do is we're going to get F net equals mass, which is 30 times acceleration, which is 58. And that equals 30 times 58 is 1,740 newtons, capital N. And that's what we get. It's got to be capital N because that's how we measure force. Anytime F net equals, we got to end with an N. Okay, we don't have a direction here, but we'll get there. A cat is accelerating at 21 meters per second squared, and it has a mass of 3.2 kilograms. Okay, if that's the case, what do we know? We know our acceleration, and we know the mass. We know it because of the units, and it says mass of, accelerating at, and meters per second squared. Lots of hints. And so we're going to use our formula, which is F net equals our mass, which is 3.2 kilograms, times our acceleration, which is 21 meters per second squared. So we got 21 times 3.2, and we get 67.2 newtons. Right? So it doesn't take that much force to get this thing accelerating compared to a 30 kilogram dog, right? 10 times the mass. It takes a lot more force to do bigger acceleration. Okay, next question. So we can use the formula. This one's different. We got two men pushing a box. So we've got a box and we've got two guys pushing it. I'm not going to work too hard on this. Two guys, right? They're both pushing this box with 300 newtons each. So it's 300 newtons two times. 300 newtons. And we're asked to find the net force. Well, it's easy to say, oh, there's a force, 300 newtons is the answer. But there's two guys applying 300 newtons, and so our net force, F net, equals 2 times our 300. And that equals 600 newtons north, right? Because they're pushing north. We know a direction, so let's state it. If we have north, let's say north. So 600 newtons north. That should be our final answer. Try this one by yourself. And then once you're ready, so press pause, try the question, and then once you're ready, turn it back on and you'll see what you get. Okay, a box is being pulled by 4 forces. So what this looks like, I'm going to draw a little force diagram. I'm going to ignore the normal force and gravity for this question. We've got, well, let's just be clear. We care about east and west here. So let's say this way is east, because it is, and this way is west. We've got 350 newtons east. So I draw a line. This is my 350 line. Okay, newtons. 250 newtons north, so it should be a bit shorter. 250 newtons. We've got 400 newtons north. Oh my, so this should be like there, 400 newtons, longer than the 350. And that's west, and 100 newtons east. Okay, so this is a pretty short line. 100 newtons east. Okay, and we're wondering what the net force is for each of these questions. We have 4 forces. Now what do we do? Well, do we just add them all up like we did here? 300 plus 300? No, because some are in different directions. And so the total force going this way is 650 newtons, okay? But they're pulling against the total force here, which is 450 newtons. And so knowing that forces will cancel if they're in opposite directions. Okay, they will cancel if they're opposite directions. So the net force in this case is going to be F net is going to be sorry about this. F net is going to be equal to 650 minus 450, which is 200 newtons. And pay attention to direction. It was west was the one that won out, right? We are going to definitely have this one being bigger. And so 200 newtons west is our final answer. We have to pay attention to our direction. Okay, I could show you all kinds of formulas, but the formulas are more confusing. You just got to think about it. Think about what directions they're going, and the bigger one is the direction that it's going to end up going in. Okay, that's the important part. So we can find net force 2 ways. If we're given mass and acceleration, we can use the formula. If we are given different forces that are applying, it is the overall force that is applying. Okay, and so let's do 3 more examples here. If you're feeling okay with this, pause the video at any point. Pause the video, try the question ahead of me. That's a much better way to learn, to see if you're getting it, to try it, to think through it. If you're just watching passively, you're not going to learn nearly as much as if you push yourself a bit. Okay, let's remind ourselves what the triangle is here. Our triangle looks like this. Draw it for yourself. Get used to drawing this regularly. F net equals mass times acceleration. So it looks like this. A golf ball is hit with a force. This is our F. And it's the only F, so this is our F net, which is convenient. And it is hard enough to accelerate the ball from rest at this, which is, if we look here, it's an acceleration. This is our A. What must be the mass? We're looking for the mass. So we're looking for this guy, the mass. We're going to do mass is our F net divided by our acceleration. And so if we plug this in, we get mass equals our F net, which is 143.52, divided by our acceleration of 3120. And that gives us an answer of 143.52 divided by 3120, 0.046. Kilograms is our units. Mass unit in physics is going to be kilograms. Okay, so there's our final answer. 0.046 kilograms. We did this up here. Mass is in kilograms. Okay, a 70 kilogram, there's a mass. We're just talking about that. There's our mass. Skydiver jumps from a plane and accelerates at 9.8 meters per second squared. There's our acceleration. until he reaches terminal velocity 56 meters per second. This is our velocity. Okay. Draw a force diagram of the skydiver before and after hitting terminal velocity and calculate all known forces. Well, we can figure out a force right away because we know his mass and his acceleration. So initially, the force, the net force when he jumps out of the plane is the mass times acceleration. And so this is 70 times 9.8. And that equals 686 newtons. 686 newtons. Okay, so that's his initial. So let's draw him jumping out of the plane, arms spread, and this is initial. So this is before he's at terminal velocity. What's pulling him down? I'll draw this in a different color, purple for forces. The force down is the force of gravity, right? And it, at the beginning, is 686 newtons. And it is causing him to accelerate. And the force of resistance is very small, okay? Force of friction is very small. This is what he would look like when he's falling. And now he's going to start falling at terminal velocity. Okay, terminal velocity means he's no longer accelerating. So at terminal velocity, what this guy's going to look like is he's still going to be flying through the air, right? No big deal, falling. What's going to happen to the force of gravity? The force of gravity is still going to be there. It's not that that stops. The force of gravity, and it's still going to be 686 newtons. Okay, which is the acceleration of gravity. It's still applying on him. But what's going to happen is the force of friction has also grown so much that it cancels out the force of gravity, so he no longer is accelerating. So the force of friction here is also going to be 686 newtons, but it's going to be up. So it's going to be canceling, which means here the net force is going to be 0, whereas here the net force at the beginning was 686 newtons down, right? And so this is, this was before, like right out of the plane, and this is once he's reached terminal velocity. And here's force diagrams, okay? The longer the line, the more force. We can calculate forces, and they're important. This is a big idea. Is he moving? Yeah, he's moving very fast. He's moving at 56 meters per second, okay? But there's no net force. The forces are balanced, which means he's not accelerating, which means he's not speeding up or slowing down. He's moving at a constant speed. All right, so that's that question. Last question, a 7.2 kilogram cat, there we have a mass, okay, is being pulled by three different children from the head, 30 newtons south, by the tail, 10 newtons north, and by the left rear leg, 40 newtons north. Yikes, bikes. So this cat here, let's just draw it as a circle, is being drawn. Let's just say that this is north and this is south. Okay, I know it's not, you'll probably like it better if I do up and down, right? Okay, north and south. It's being pulled north 10 newtons. It's also being pulled north by 40 newtons. And it's being pulled south by 30 newtons. And so we don't have the net force at this point, but we can figure it out. There's 50 up, 30 down. So F net in this case is 20 newtons north, or up in this case, which is north. All right, 20 newtons north. Those two ends mean two different things. Newtons for the first one, north for that one. So what's the acceleration? Well, we can't use any of the forces. We have to use the net force, which is 20, but we can use the mass. And so if we look up at our triangle, we know the mass, and this time we want to find the acceleration. Okay, so we're going to do F net divided by m. Remember, it's got to be the net force. You can't use anything else. And so our acceleration equals F net divided by m, which is 20 divided by 7.2. And that gives us an answer of, just to be clear, this is 7.2 kilograms and 20 newtons, right? And that gives us an answer of 20 divided by 7.2, 2.7777, which is 2.78 meters per second squared. There, squared. There we go. It has to be meters per second squared because it's an acceleration. And we could extend questions like these, which you will see in your worksheets, is if the cat starts from rest, what's its velocity after 2 seconds? And so this is no longer an F net equals ma question. This is now, well, you have an acceleration. Why don't you find velocity? Okay, so if it starts from rest, what's this change after 2 seconds? So we need a different triangle for this. This is up top. We've got them all here. We have an acceleration and a time, and we want how fast it's going. And so this triangle looks like this. This is the A equals the change in velocity over time. We just did that video, maybe. I did. And so you should too. It's a great video. You should watch it. It's amazing. It's going to change your life. We are looking for the change in velocity. And so we're going to do A times T because delta V equals AT. And so what we're going to do is delta V equals the acceleration, which is 2.78 times time, which is 2 seconds. All right, that gives us 2.78 times 2 is 5.56 meters per second. And that's the velocity of the cat that is being pulled by 3 kids after 2 seconds. Now, isn't that a nice picture? I think that covers basically everything. We've got force diagrams, okay, how to draw force diagrams. There's the force of gravity, the force of friction. If we look here, I'll add some real quick things if you're still following. Technically, these always exist. Even here, there was the force of gravity on this box. It was not being pulled down by a person, but it is by gravity. But the ground usually stops it unless you're in free fall. And that force of the ground stopping it from falling through it is called the normal force, and we call it Fn. So these are good things to add as well, to have in a proper force diagram. So we went over that. We talked about how it takes multiple, our formula is always F net, which means if there's multiple forces, they will add together if they're in the same direction or cancel out if they're in opposite directions. And we always have to find the net force before we say we're done. And the other way you can find the net force is with the formula F net equals ma. And so if you have more questions, then feel free to email for more work or for just to ask questions. And my encouragement to you is to go to the review that you have or other unfinished work and do questions with forces in them and practice. Now you've walked with me through this practice, so keep practicing. Don't quit now. Just because you watch doesn't mean you're ready to go. You're going to just improve by practicing more. So keep going.